They told us it was impossible. The longest suspension bridge in the history of the world, the deepest underwater foundation work ever attempted. 83,000 tons, or 75,000 metric tons, of structural steel suspended above the most violent tidal currents on the planet. The construction timeline? Exactly 4 years and 5 months. The official historical narrative dictates that the Golden Gate Bridge is a triumph of the human spirit. We at Titanmetrics dictate that it is a logistical and kinetic paradox. Welcome to the audit. Let us look at the baseline metrics. The year is January 1933. The unemployment rate in the United States has violently spiked to 25%. The country is bankrupt and economically paralyzed. $35 million in debt at the absolute rock bottom of the Great Depression. Ground is broken on a megaproject that will dwarf anything humanity has ever attempted. This is where the paradox begins. How did a starving nation manage to mobilize, manufacture, and transport this colossal volume of raw steel and heavy machinery to one of the most geographically hostile points on the American coastline? And how did they do it faster and with more precision than the vast majority of modern infrastructure projects today, which are backed by supercomputers and automated supply chains? We do not believe press releases. We believe in physics. We believe in metrics. Let us open the ledger.
To understand the sheer scale of this structural anomaly, you must first understand the geography. The Golden Gate Strait is not a lazy river. It is a violent, 2-mile-wide bottleneck. Every time the tide changes, the entire water volume of the massive San Francisco Bay is violently forced out into the Pacific Ocean and then sucked back in. It is a hydraulic trap. First, the depth. At the precise location where the South Tower was designated to stand, the bedrock was over 100 feet, or 30 meters, below the surface. Second, the currents. The water moving through this strait travels at speeds exceeding 10 miles per hour. That is not a current. That is a subterranean whitewater river. Third, the atmospheric conditions. The entrance to the bay is globally infamous for its thick, blinding fog and gale force winds that routinely clock in at 60 miles per hour, or 96 kilometers per hour. When the top structural engineers of the 1920s looked at this site, their consensus was unanimous. The word they used was impossible. They stated on the record that building a 700-foot tower in water that deep, with currents that fast, was architectural suicide. They stated that steel suspension cables of that unprecedented length would simply sag and collapse under their own dead weight. They stated that no bonding company on Earth would ever underwrite the financial risk. And the ultimate enemy wasn't even the ocean. It was the money. The country was utterly bankrupt. The idea of issuing $35 million in construction bonds to finance this madness was viewed as borderline criminal. Yet somehow, it happened. The cities and counties surrounding San Francisco, communities that were themselves on the brink of total financial ruin, voted to take on this crushing debt. They tell you it was just civic duty and patriotism, but Titanmetrics looks for the logistical reality. In 1932, a year before the ground was broken, practically only one man in the world, Chief Engineer Joseph Strauss, believed this was actually viable. How did this absolute chaos, financial, geographical, and political, magically transformed into a synchronized, ticking clock that started on January 5, 1933? We do not have that answer. We only have the data.
If you want to find the anomaly in a megaproject, you follow the materials. The primary structural element of the Golden Gate Bridge was steel, 83,000 tons of it. And here lies the first massive logistical fracture in the narrative. In 1933, on the entire west coast of the United States, there were 0 steel foundries capable of producing structural components of this magnitude. The closest facilities on the continent with the blast furnaces and tooling required to forge this bridge were located in Pennsylvania and Maryland, on the opposite side of the continent, over 2,500 miles away. Almost every single ton of steel for this bridge was manufactured by Bethlehem Steel at their East Coast plants. We are talking about gigantic monolithic struts, some weighing up to 40 tons each, alongside tens of thousands of tons of complex interlocking lattice structures. They tell you they just shipped it over. Titanmetrics is conducting a supply chain audit on that shipping. Mainstream historians will eagerly point out that some of the steel was shipped across the country by rail. Let us grant them that theoretical efficiency. But a 1930s railcar could carry a maximum of 40 tons. To move 83,000 tons requires a continuous, synchronized armada of over 2,000 heavy freight cars crossing the Rocky Mountains in the dead of winter. And for the massive components, the only viable method was by sea, through the Panama Canal.
Let us digitally reconstruct this transit route. The steel is forged. It is loaded onto heavy-duty freight trains at the Bethlehem Steel plants. These trains travel hundreds of miles to eastern seaports like Philadelphia. At the docks, the massive steel components are craned onto giant ocean-going freighter ships. These ships embark on a grueling 5,000-mile journey south, navigating the locks of the Panama Canal. Once through, they execute another 3,000-mile journey north, up the jagged coastline of California. Finally, weeks later, they arrive in the San Francisco Bay. That is an 8,000-mile logistical marathon for every single piece of steel, repeated hundreds of times. And this was executed with an absolute 0 presence of modern GPS tracking, 0 digital manifests, and 0 automated port logistics. The entire coordination of this transcontinental supply chain was executed using nothing but landline telephones, telegraphs, and physical mail. Understand this. They did not have massive sprawling staging areas in San Francisco to just dump 80,000 tons of metal. The steel had to arrive precisely when the rigging crews were ready to hoist it up the tower. It was a 1930s version of just-in-time manufacturing on a scale that boggles the modern mind. One catastrophic failure in the Panama Canal, one freighter lost to a Pacific storm, one major miscalculation in the blueprints, and the entire construction timeline would have stalled for months. But the official ledger shows no such delays. Mainstream historians will eagerly point out that Bethlehem Steel was a global maritime titan, accustomed to the Panama route. Let us grant them that. But the level of analog manual coordination required to execute this without a single lost freighter defies modern project management. In an era of supercomputers, we struggle with supply chain delays. They did it with paper and telegraphs. That is the true logistical anomaly. But we are just getting warmed up. Let us descend to the bedrock.
For those in the comments who will inevitably claim that this was all just basic 1930s engineering, let us look at how they actually built these towers. Standing 746 feet tall, they were the highest suspension bridge towers on the planet. But the paradox isn't found in their altitude. The paradox is found in their foundation. The North Tower was situated on dry land in Marin County, structurally straightforward, but the South Tower. Chief Engineer Strauss planned to plant the South Tower 1,100 feet offshore, sitting in 100 feet of dark, freezing water, precariously perched on top of a sloping serpentine rock reef, dead center in the most violent tidal currents of the Pacific Ocean. Any marine engineer of the 1930s will tell you that is impossible. The hydraulic force of the current will instantly wash away any concrete pour and obliterate any wooden formwork. You cannot stabilize a worksite in those conditions. But titanmetrics doesn't deal in impossible. We audit what was actually built. To construct the base of the South Tower, they built a massive concrete fender, a cyclopean, oval-shaped fortress ring made of concrete, with walls 27 feet thick. This fender was designed to encircle the future foundation site, acting as a massive shield against the crushing ocean currents. But before they could build the wall, they had to level the sloping bedrock at the bottom of the sea. How did they do this in 1933? They used dynamite. Deep-sea divers wearing incredibly heavy, primitive brass helmets and canvas suits were lowered 100 feet into the pitch-black, freezing, raging currents. They physically planted high-explosive dynamite charges by hand. They were pulled up, the charges were detonated, and then the divers went right back down into the murky abyss to manually clear away the jagged rock debris with high-pressure hoses. They tell you these were just brave divers. We at Titanmetrics call this a forensic engineering anomaly. They were detonating high explosives underwater, manually clearing a seabed in conditions that modern safety regulators would instantly classify as a suicidal risk. And they did it. Without a single recorded fatal accident during the underwater blasting operations.
Once the bedrock was level, they poured the concrete, but you cannot pump water out of an open hole in the ocean. They had to pour concrete directly through the seawater using a technique called a tremie pipe. While the method existed, attempting it at this cyclopean scale, in the middle of a Pacific tidal bottleneck, was considered engineering madness. They poured tens of thousands of tons of concrete through a pipe into the ocean to create a massive underwater plug. Only then did they pump the seawater out from the inside. They literally created a dry, empty room resting on the floor of the Pacific Ocean. We are talking about a staggering volume of material, 100,000 cubic yards of concrete for the South Tower base alone. How did they coordinate the diving bells, the high explosives, the manual rock clearing, and the continuous, flawless pouring of 100,000 cubic yards of concrete, all while violently fighting the tidal forces of the Pacific Ocean without modern hydroacoustic mapping or underwater robotics? That is logistical anomaly number 2. And we haven't even mentioned the 600,000 steel rivets driven into each tower by hand, caught mid-air while red hot by men balancing over the void. Now look up.
If the foundations of the towers were mathematically improbable, the main suspension cables were physically unthinkable. The towers do not hold the bridge. The towers merely hold the cables. The cables hold the bridge. The suspension cables for the Golden Gate Bridge are the most massive ever spun in human history up to that point. Each of the 2 main cables has a diameter of 36.5 inches. That is nearly a full meter of solid steel across. They tell you these are just steel ropes. Titanmetrics conducts a volumetric audit. These cables were not cast in a foundry. They were not woven in Pennsylvania and shipped over. Transporting a single finished steel cable weighing 12,000 tons on a ship through the Panama Canal is absolute fiction. These cables had to be created in situ, on site, suspended in midair. Each of the 2 main cables is composed of 27,572 individual steel wires. Each wire is roughly the thickness of a standard lead pencil.
The spinning process involved taking a single wire, pulling it all the way up and over the top of the 700-foot towers to the other side, anchoring it, and then pulling it all the way back. One of the leading bridge engineers of the era, Othmar Ammann, estimated that spinning the cables for the Golden Gate Bridge would take a minimum of 2 full years. This was the Great Depression. Time was quite literally money. Strauss contracted John A. Roebling's Sons Company, the exact same legendary firm that built the cables for the Brooklyn Bridge, and they engineered what titanmetrics classifies as a temporal logistics paradox. The cable spinning officially began in September 1935. It was entirely completed in June 1936. Ammann said it would take 24 months. Roebling did it in 8 months. How is this physically possible? Roebling's engineers redesigned the entire physics of cable spinning. They engineered a split spinning wheel system that pulled multiple wires simultaneously. They essentially built a mid-air industrial assembly line, operating at 700 feet above the ocean, constantly moving at 650 feet per minute. But let us audit the final numbers.
The length of a single wire going across the bridge is roughly 8,000 feet. The total number of wires in both cables is over 55,000. Calculate the math. That gives us a total wire length of 80,000 miles, or 128,000 kilometers. That is enough steel wire to wrap around the equator of the Earth 3 full times. And this entire volume, 80,000 miles of wire, was manufactured, transported, woven mid-air, bundled, perfectly tension-aligned, hydraulically compressed, and permanently anchored in just 8 months in 1935. There is a severe lack of modern logic here. You cannot coordinate 80,000 miles of steel wire without a single critical tension failure, without a single catastrophic snap, using analog technology. They did not have laser alignment. They did not have computer-controlled tension sensors feeding data back to a central server. Every single adjustment, every single tension check was done manually by men standing on swaying catwalks in the freezing fog. How did they achieve this impossible speed and this unthinkable microscopic precision with a complete absence of modern digital automation? That is logistical anomaly number 3. Which brings us to the final and perhaps most disturbing audit.
If you still believe this narrative is flawlessly straightforward, let us look at the human cost. Let us look at the blood. They tell you Joseph Strauss was a pioneer of workplace safety, and the historical ledger supports this. In the 1930s, the brutal, unspoken rule of mega construction was simple: 1 death for every $1 million spent. The budget for the Golden Gate was $35 million. The grim expectation was that 35 men would die building it. Strauss refused to accept that metric. He made safety his absolute obsession, and in doing so, he created what titanmetrics calls Anomaly number 4. Strauss spent a fortune strictly on safety innovations. He mandated that every single worker wear a rigid helmet, making it the first construction site in America to enforce hard hats. He designed specialized safety belts, and most famously, he installed the net. A massive safety net, similar to a circus trapeze net, was suspended beneath the entire span of the bridge. It was a revolutionary, expensive intervention for the 1930s. They tell you it saved lives. We at Titanmetrics audit the kinetic reality. The net saved exactly 19 lives. 19 men lost their footing, plummeted from the steel, hit the net, and survived. Because of this net, a project that was mathematically guaranteed to kill 35 men had, over the course of 4 brutal years, claimed only 1 single life. 1 worker died in a localized derrick accident. How is this possible? In the depths of the Great Depression, when desperate men were willing to take any risk for a paycheck, how did Strauss engineer this dazzling, near-perfect record of survival? It is a human logistics anomaly. But then, just 3 months before the bridge was scheduled to be completed, the matrix broke.
On February 17, 1937, a heavy, multi-ton scaffolding platform tore loose from its hangars. It plummeted down, carrying 12 men with it. Here is where the official narrative fails the physics test. The safety net was designed to absorb the kinetic impact of a 200-pound falling human. It was not designed to absorb the kinetic shock load of a 10,000-pound steel scaffold free-falling from the sky. The platform hit the safety net with such immense, concentrated kinetic force that the net violently tore away from its moorings. 2 men survived the 200-foot plunge into the freezing waters below. 10 men died instantly. They tell you it was a tragic, unavoidable accident. But titanmetrics looks at the physics. The net, the very instrument engineered at great expense to save human life, ultimately became the mechanism that trapped them and pulled them down into the abyss. Out of the 11 total men who died building the Golden Gate Bridge, 10 of them died in one single catastrophic instant, just weeks before the finish line. How does an unthinkable triumph of industrial safety, 1 death in 4 years, become instantly stained by this sudden, chaotic collapse at the very end? It was not a coincidence. It was a devastating reminder of the unforgiving kinetic reality they were fighting. The matrix didn't just break, it violently corrected itself.
Let us close the ledger on this audit. The official historical narrative demands that we accept the Golden Gate Bridge as a simple triumph of man over nature. The data at titanmetrics demands that we look closer. We see an 8,000-mile transoceanic steel supply chain functioning with 0 critical delays. We see massive concrete foundations poured at the bottom of the Pacific Ocean using 1930s dynamite, brass diving suits, and cyclopean tremie pipes. We see 80,000 miles of suspension wire spun and perfectly calibrated in 8 months, defying the greatest engineering minds of the era. And we see a safety record that was mathematically flawless for years, only to violently self-destruct at the final hour. We do not believe in fairy tales. We do not believe in ancient magic. We believe in the forensic engineering audit. And when we audit the Golden Gate Bridge, we see an undeniable anomaly. We see a mega project executed in the 1930s, without supercomputers, without GPS, without digital automation, without modern heavy robotics. That was completed faster and with more logistical precision than almost anything we are capable of building today. How was this physically possible? We do not have the answer to that question. We are only here to ask it, and this audit is far from over. Stay locked on titanmetrics. Turn off the panic. Go back to work. We have only just begun to conduct our retrospective structural audits on the impossible infrastructure of the industrial era. Check our complete case file playlist on the screen right now to investigate other historical infrastructure anomalies. The link is waiting for you, and we are waiting for your structural audit in the comments below. Trust the numbers, not the narrative. The ledger remains open.